the online session for week 4, Tuesday. I hesitate to ask, are there any questions on the assignment? And I won't ask that because that's what the forum's for, I think. Some of the stuff I'll be telling you today might actually be useful for the assignment. So let's see. All right, so last week we'd started, yes, wink, wink. Last week we'd started answering questions on a beers database, and I realized, oh, I'm on the wrong machine. That's not going to help. Oh no, maybe it will help. Let's see. Oh yes, there we go. So having done that, I now realize that the place on the machine I want to be is VXDB. This is an alias of mine, saves me doing a bit of typing. I'll have to do that all again. Oh, not S1. Oh, what? Do I have something there? I do. All right, I even have solutions, and they say week 3. Irrelevant. All right, let's get going. Yeah. The database, looky, haven't got a database set up, but at least I can see from this error message that I've set my environment up correctly because it's saying local storage. All right, start the database. Stick. Yeah, last time I was using this database, which was more complicated than the one I was anticipating. So I'll use this one, which is a little bit simpler. And it makes the same points without so much SQL. Can we get dump file? Yes, you can. You want it now? That might be tricky. Yeah, good. Because I'm not sure where it came from. Oh, well, yes. I found it somewhere, probably under the class account. Anyway, I'll dig it up and give it to you. All right, what beers are made by TUIs? Let's see, what tables have we got? We've got a table all about beers. What do we know about beers? We know name, brewer, and style. So this is much simpler than the assignment database. All right, so clearly we're interested in the name from beers. And the whole point of this question was that you had to double up the quote inside the string. So there, yeah, if you want to have a single quote in a string, you got to double it up. Well, also a bit unclear. Yes, I will definitely cover. Oh, I'm not going to cover partitions. I might have a look at it later, but not today. Why not backslash like a normal language? Funny you should say that. If you really want to, then you can do this, I think, which is a PostgreSQL special. It means extended strings. So if you stick an E in front of the string, then you can use backslash. But if you don't stick the E there, then you're going to get this. You might say, what's going on? Well, if you look closely, you can see that the prompt has changed to put a quote there. And basically what that's telling you is that you have a string that you haven't completed. And basically what's happening here, you've got two E's, the string. This is the closing quote to that string. Then we got S, meaningless, so we would have got a syntax error. Then we start a new string, and just following that is a semicolon. And the only way to finish this off is to type a quote and then put the semicolon. And then it tells us, hey, hey, we had a mistake near S. So this would have formed the string 2E backslash. Not useful, but all right. Show beers with headings beer and brewer. I talked about that last time. You use as, so you can always rename. Let me quickly. Oops, I'm not inside VI. So you can rename an attribute using as, and if you want the name to appear exactly as you wrote it, you put it in double quotes. If I didn't put the double quotes, it would all be mapped to lowercase. So what sucked in. I know what I should do. I should use \E, where it would be easier to see what's going on. And I'd get syntax highlighting. Change that, get rid of that garbage. And now it's going to give the same query, but now it puts a header, or it changes the name of the attribute and maintains the case because it's inside double quotes. How many different beers are there? Yeah, just using count. How many different brewers are there? Using count distinct. Pairs of beers by the same manufacturer. That required you to join the beers table with itself and then find the tuples that had the same manufacturer. So you can kind of see what was going on. Select a dot name, a dot brewer, a dot name from. And here I'm effectively doing it as like naming of the tables. And generally I'll do it to a single letter because it's much easier to type the rest of the query. Yes, there is a dump file somewhere, but I can't find it at the moment. And we're joining on a dot brewer equals b dot brewer. All right. Yeah, that'll do. So, all right. So here we've got 80 shillings is made by Caledonian, and 80 shillings is also made by Caledonian. So this kind of tuple isn't exactly useful. Here is a tuple that is slightly useful. Actually, I'll change the output format because that's messy looking. This \x writes the tuples like that, so it's a little bit easier. So we got a beer, amber ale, brewer James Squire, Nine Tails, which is also made by James Squire. So at least here we've got pairs of beers made by the same brewer. To get rid of these duplicates, I said you should check a.name less than b.name or something similar. So then it will only give you one pair. So the way I've set it up in the moment, eventually we'd find Nine Tails as the first name and amber ale as the second name. So we don't want those duplicates. All right, pairs of beers by the same. Which beers does John like? Find the brewers. Oh, I don't think we did that one last time. All right, so in this database, we've got bars, beers, drinkers, frequents, likes, sells. So likes is a table that connects drinkers to beers, and it's obviously the beers they like. Now, in this database, the primary keys are all the names, which makes it a lot easier to do these kind of queries. Then, okay, they're the same table, but I've just given it two different names because I need to join it to itself. Oh, well, maybe. All right, maybe I did do this one last time, but it was on a different database and I had to do a join to get the name of the drinker and the name of the beer. Here they happen to be in the same table. So, which beers does John like? Okay, so that's, wow, I like a lot of beers apparently. This is a slightly larger database than the one I was thinking of, but in any case, that's fine. All right, so which beers does John like? Now we want to find out who brews those beers. So here's one way you could do it. And a lot of the textbooks actually do things this way. I'll edit. Jazz goes through coding with me on pair of beers. But yeah, I know. Right. So what we now want to get is brewers, and we want to select from. Well, someone asked on the forum about formatting queries. I tend to do them like this. Here's one way you could do it. So basically what you're asking here is find me the brewers from the beers table where the name of the beer appears in the set of beers that John likes. So in is set membership operator in SQL. Notice in the likes table, the beers are called beer. In the beers table, they're called, well, the name of the beer is called name. So hopefully that's one way you could solve this query. And I get the brewers, but I get some duplicates. So presumably I'd want to change the query to, I don't need to be told twice that I like beers by Brewdog, so I could do that. Generally, that's not a great way to do things using this nested query. It's often better off using joins. So select beers, B join L. Oops. And we need to join on the beer names, and that means the attribute called name in the beers table has to be equal to the attribute beer in the likes table. And if I just did that, I'd get a whole lot of stuff that I'm not interested in. So I need to filter out just the stuff where L.drinker, I think, is the tuple where equals, is the attribute is equal to John. And that gives me the same set of, yeah. The reason I didn't use lowercase l for this alias is because it ends up looking like a 1. So, I mean, I could have called it K or something because there's a K in the name, or I could have just called that A or whatever. Wouldn't you generally want a foreign key to be, well, no, not necessarily. You'd name it so it made sense in the context. And having an attribute called beer in the beers table, so you're really talking about the name of the beer. So it makes sense to call it name in the beers table, but in the likes table, you're referencing a beer, and the beer attribute is the name of a beer. In the database I used last time, I'll call it beer name in both, all right, if you like. I don't like using long names if I can avoid it. So I probably wouldn't do that. But yes, you are correct. Here I've named it, I think, so that the queries come out pretty small so that I don't spend a lot of time typing. All right, anyway, so that's that query. Find beers sold at the bars where John drinks. Okay, so this is going to be a similar kind of thing. We need to find the bars where John drinks and then find all the beers that are sold at those bars. So how do we know where a drinker drinks? There's a table called frequents that tells us that. This is the kind of thing you need to do when you're faced with a query like this. I talked about solving queries. When someone says that, I'm interested in beers. So the output is going to be the name of some beers sold. So I'm interested in where the beers are sold. I know there's a table that tells me that. Bars, there's a table of bars, but the bars I'm interested in are these ones. So there's a frequent table. So the English isn't necessarily going to be, the English in the question isn't necessarily going to be the same as the name of the tables. So you have to do some mapping. So I could start off and do it similar to the way I did it. So select bars from frequents where drinker oh yeah, silly me. Get the name. It's actually singular when we're doing attributes and plural when we're doing tables. All right, so that's the set of tables that I apparently frequent. Totally untrue. I haven't been to any of those tables recently. Oh, how do you edit the last command? \E, which is going to drop you into whatever you specify as your editor in your environment. And what I've specified in my environment as the editor is VI. If you don't, oh God, yes, indeed, shout out the VS Code game. Probably doesn't work. Dropping into there. The default editor is VI, so unless you change it, then you may get stuck at this point. \D means describe, I guess. if you want to know what, oh, I was actually in, actually I'll finish this off. All right, so what was the, find the beers sold at the bars that John frequents. All right, so that's the set of bars that John frequents. And then we need to find the beer names from cells from, oops, from the cells table where the bar in the cells table is in. So one thing you can see, well, I'll probably should put that on the next line. Yeah. One thing you can see is you don't need to have these table aliases because it can work things out from the context. So SQL knows that this bar here is the one, is the attribute in the cells table, and this bar here is the attribute from the frequents table, which allows you to get away with, yes, thank you for solving that conflict between VS Code and VI. All right, so this should give me a list of the beers that are sold in the bars that I frequent. How do I know that? Good question. How do I know which bars they're sold at? And you can also see there are some duplicates. So the obvious way to fix that is to stick a distinct. And I guess if I was really keen to know what bar it was, I could add that in. Right, so now we know where each of those things is sold. Now we've still got new repeated because it's repeated at 3 different bars. Oh, which is an interesting thing. I don't want to have 3 tuples. I want to have a single tuple that has new and the name of those 3 hotels. How can I do that? This jumps ahead to, where are we going to do that? Queries on simple aggregates. It jumps ahead to aggregates. All right, so we've already seen a few of these. Min and max give you the minimum and maximum value in a column of numbers. Actually, it doesn't have to be numbers. It can be strings as well. Anything that has a comparison, has an ordering. Average will give you average value in a set of numbers, and count just counts the number of tuples. That basically counts the number of tuples. If ABC is a primary key, then this value here will be exactly the same as this value here. If ABC is not a primary key, I think it'll still be the same. But if you don't want to count all the occurrences of the same value, then you can use count distinct. Another kind of aggregate is the thing for gluing strings together, which is basically the one we want here. Null values counted too. Good question. Very good question. I don't think they're counted if you do it like this. If there's a tuple where the attribute ABC has a null value, it won't be counted. So this is one place where they are different. This would count all of the tuples regardless of what values are contained in those tuples. So, I mean, your average tuple is not likely to have all null values. So there'll be a tuple possibly with null values interpreted, but inside it. But we're counting tuples here. If there are some tuples where the attribute ABC has a null value, they won't be counted, but we'll still count duplicate occurrences of ABC values. And here we won't. All right, good question. All right, so there's a thing called string ag, which glues strings together. Here I'm going to separate them by a plus. And if I want the things that have been glued together to appear in a particular order, I can do it like that. So I'm going to copy this and hopefully it will paste okay. So what I want to do now is look at this group of tuples and turn them into a single tuple which has these three strings glued together and separated by commas. Now, have we got any other examples of this? No, we don't. No, well, that's a bit boring. But anyway, we want to get rid of this replication of new, and say all of the places where new is sold. Wow. Right, this query is starting to get complicated. This is pretty not a great way to build up a query. So we want to group by beer, and so that will take each of those groups of tuples that have the same beer name and treat them as a group, and within that group we want to glue all of the bar names together. So in fact, oh, I know, did that work? Yes, it did. Cool. String ag. So within a group of beers called new, there's 3 bars mentioned. Now I'm going to glue those bars together, and I can only do that where I have grouped according to beer. So all the tuples containing new will be treated as a single group, and within that group I glue the names of the bars together. And I don't, once I've said that group by beer, I don't actually need distinct anymore, because each beer is only going to appear once based on the group by, and then we've got all of the bars. So shut up, stop talking, go and run the query and see if it works. No. What? Salisbury must appear in a dozen. All right. That's probably true. It might have. Oh, no. That's what the error was from. I must have left a semicolon sitting around. Let's see. Yeah, you can see that semicolon here. That's caused the problem. Let me see if I can back up and get rid of it. All right. These all work. Good. All right. So you can see these 3 bars that sell new have all been glued together. And I can't quite see the comma after Coogee Bay Hotel and then Lord Nelson. All right, because that part of my window is covered by the chat. And everything else was, could you just show the query? Well, yes, sure, I will, because I was actually going to change it. I was going to say, well, look, we got all these groups of bars. Maybe it would be more interesting to look at each bar and have a look at all the beers that are sold at that bar. And that's pretty easy to change. Let's go back. Find the beers sold at bars where John drinks. Well, you could do that. You could actually. So there's the original query. And what I'm about to do is sort of flip it around and say, I want the bar and I want to glue together all the beer names that appear in that bar. And and I want to group by bar now. Well, order by bar isn't really helpful. Order by, yeah. And then I'll get something like that. So in fact, if you remember the original query, find the beer solid bars where John drinks. The original set of bars where I drink is Australia Hotel, Coogee Bay Hotel, Local Tap House, and the Lord Nelson. And now I'm just showing all the different beers that are sold in each of those bars. Just to show you a very common, will the query work? No. Yeah. So I was about to show you some error cases. Without the string ag, it's a bit of a mess because basically, if you make a group, then sure, the thing that you're grouping by appears as an output attribute. Anything else that appears here has to be a single value. And the only way, does it take all of these? Will the query work without the string ag? No, it won't. Show up in the groups. String ag works. Does it take all of these entry that show up in the groups formed by group by bar? Yes, that's exactly what it's doing. Right, if I change the group by to order by, it'll kind of make it a little bit clear what those groups are. Oh, so yeah, now I can't have the aggregate. All right, so cells bar must appear in the group by clause to be used in the aggregate function. So I can't use an aggregate if I'm simply ordering by. So, and that's a very common mistake to make. Let's see, cells has price. All right, so let's say I wanted to put the price, and let me change that back to group by. Now, kind of doesn't make sense to talk about the price because the price can be different in each bar. And so you're going to get the same kind of error that says this attribute has to appear in the group by if you want to use it as an attribute in its own right there. So let's, all right, cells.price must appear in the group by or be used in an aggregate function, right? So one thing I could do is I could say, what's the maximum price for at this particular bar, and then all of the beers that are sold at that bar. Now that's not, in fact, maybe even better might be to say, what's the average price? To use concat, what's concat? I don't think concat exists as a thing as a function in PostgreSQL. I'll have a look though. There may be a function, but it might not be a. It might not be an aggregate. All right. So now here we can see. All right. Apart from the crappy formatting, you can see the average price at each of these bars and the list of beers that are sold at those bars. Of course, it doesn't really tell you anything about how much this beer cost or how much, another beer cost. Use string ag. That seems to work. Yeah. All right. Concat. And you asked about concat. Let's take a look. Concat, lower or upper concat, string functions and operators. Where are showing? Yeah, okay. It's not going to work for the assignment because it simply sticks all the strings together and you can't put separators in like what you need for the question 10, as everyone is telling you. All right. Let's go back. Yeah, so fair bit going on there. Any questions? I mean, you know, I could do something much simpler. I could get the average price and the maximum beer, which should give me the beer with the type case. I don't know what that means. All right, so it's a silly thing to do with strings, but it's saying what string has the alphabetically highest name out of all the beers at that bar. All right. Typecast the every. Oh yeah. Okay. Good point. Yes. Right. What did you say? Can you type case? That's what confused me. I think we might be able to do something like this. Actually, there's a money data type, but I'll try the numeric one first. Let's see what that does. Oh, and you probably, when you do that, said what? Oh no, really? As oops, probably doesn't matter doing that. Yeah, all right. So you can typecast, and in Postgres, typecast is double colon. How to find. Oh, that was fun. You can work out. Basically asking for another part of the assignment solution. Oh, what? Cannot cast type double precision to money. Oh, well, in that case, use numeric. Well, I think we've done that query to death. Oh, the other thing I could have showed you, once again, it's got a subquery. You don't need to do that. You could use a join, and I'll leave that as an exercise for the reader. All right, bars where either Gernot or John drinks. Oh. All right, so we kind of back from frequents where right, so we look at the frequents table and we look for these drinkers, and we should get something like that. We got any duplicates there? Yes, we do. And that's come about because if we looked at always do that. Right, so Gernot drinks at those two bars, and I drink at the Lord Nelson and the rest. So we get a duplicate if we wanted to get rid of that. We can use distinct. Oh, we're doing right. So let's Here's this query. What about the next one? Query number 9. Bars where both Gernot and John drink. Now, it's kind of simple to think maybe that is going to do the trick. Is it? Or you can tell me how many bars will I actually find by doing that? 0, exactly. Yeah. No, it is referring to Gernot Heiser. No. Or at least I just took his name in vain. Yes, you're right. I'll get 0 results because you can't have an attribute which has 2 different values. So the previous example with or, intersection, you are correct. How do we do that? All right, so basically what we have to do, where drinker equals John. So SQL has set operations. Which look like that. And for some reason, I always put, I always put the queries in parentheses. So we get the set of bars where the drinker is John, set of bars where the drinker is Gernot, and we take the intersection, and they'll be the bars where both of them drink. All right, so we both drink at the Lord Nelson, and that's all. And yes, someone's asked about union, so you could actually use union to answer the previous query, which was where either John or Gernot drinks. So that would be the union of all those bars. Another interesting thing to notice here, we've got rid of the duplicates. The semantics of union and intersection in SQL is set semantics. And if you want to enforce bag semantics, as Maria just told us, you use union all, and that'll probably leave duplicates. Da, 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 da. The other thing that you might notice, is that they've magically become sorted. How is this different to join? It's totally different to join. It's taking in fact, and has uses in the where clause. All right, I was just thinking, can we do this with a join? And I think we can. All right, anyway, the reason I put these 2 queries in was to demonstrate set operations that you've got in SQL. So you can do union, you can do intersection, and you can do set difference by saying except. And if I put that in here, it's going to give me the set of bars where John drinks, excluding the ones where Gernot also drinks, so they'd be excluded, I think. So that should dump the Lord Nelson from the list. Yeah. Okay, so bars where John drinks, excluding the ones where Gernot also drinks. I'm pretty sure you could do this with a join. by joining frequents with itself. Well, thank you. I didn't get why. So union removes duplicates. Union all. So union uses set semantics. Union all uses bag semantics, if you know what a bag is. All right, cool. Yeah, I think you can do a join. You could do frequents A, frequents B, and then fiddle around with the where clause there as well, certainly to get the to answer the AND query, and to do the all one as well for that matter. All right, here's another very common type of query. So except the order is important, yes, the order definitely is important. If I'd done it the other way, all right, before getting onto that slide. This is going to give me all the bars where Gernot drinks and where... No, that's not necessarily true. Yes. This will give all the bars where Gernot drinks, but where John doesn't drink. And that's it. So Gernot only drinks 2 bars, and one of them is the Lord Nelson, where apparently I also drink. Hadn't been to a bar or a pub for a very long time, I gotta say. Lockdown. What? I'll think about it. Suppose I could. But it'll be too late. We'll be finished with this database. All right. Yeah, what's the most expensive beer? And that's a pattern of, what is the name of the beer with the maximum price is essentially the question that we're asking here. So one way to do it, and this is why views are nice, is that you can create a view that just holds the maximum price. And because it's a single value, technically it's a tuple, but there's only one tuple and it only contains one value. So you can treat it like a value, right? So this view here is going to give us the maximum price. And then we can plug it into a query, get the name of the beer, which, this is the database I was using last time. It can be a little bit simpler. But anyway, the critical thing is working out the maximum price by doing this. You could simply plug in select max price from cells in this location as well. But view makes it slightly simpler, especially if this was a more complex query. So this kind of pattern, what is the X of the Y object with the maximum sum attribute of that object? So X and Z are both attributes of an object. And in this case, it's in the context of a bar where it's sold. And that's the table that you're looking at. So this kind of pattern is very common. What's the biggest? What's the smallest? What's the largest? Whatever. All right, aggregate. So I jumped ahead and talked about them before. Have a look in the Postgres manual. There are, this basically 921 gives you a list of all the aggregates. 427 talks about using aggregates in expressions. And this is actually where it talks about order by. And if you don't like the aggregates that you've been given, you can define your own, and we'll talk about how to do that maybe next week, maybe after Flex Week. So Postgres is quite nice. You can define your own types, you can define functions, you can define your own aggregates. And because they're all doable from the user level, lots of people have defined lots of interesting types for Postgres, some of which are so useful that they've been incorporated directly into the Postgres distribution. There is not a beer type. Aggregates and functions. All right, aggregates, as it says, aggregates are functions whose goal is to summarize a set of values. So aggregates are functions, but they have a particular role that they'll take a bunch of values and they'll give you back a single value. I'm not sure what you actually put in a beer type. Maybe I should. Maybe I should. All right, so have I answered the question about aggregates and functions? You will actually see when you define your own aggregates, you have to write some functions that become part of that aggregate. But the basic aim of an aggregate is to take a bunch of values and squash it to a single value. You can see that's what all these things are doing. A bunch of tuples, how many are there? Gives you a single count value. Min will find the largest, the smallest value. Max will find the largest value, and average will take a bunch of numbers and compute the mean value. Okay, all right, so we've already seen some examples. I kind of jumped ahead a little bit. I think these ones here also have examples of aggregates. Right, how many beers does each brewer make? Hopefully, based on what I talked about before, should be able to work that out. So if I did something like this, so select name and brewer is hopefully this will fit on a single line. Yes, of course it will, because I was using \x. All right. So here we got these groups of beers that are made by a single brewer. There's one. There's quite a large one. So we got all these beers that are made by Bent Spoke. Quiz question: where is Bent Spoke Brewery? We'll leave that to appear in the chat once someone looks it up. So anyway, we've got this group. Oh, well done. That's quick. Yes, it's in Canberra. Was this in the lectures? Was what in the lectures? The location of Bent Spoke? No, it wasn't. But it will be in the exam. What? What? I don't know. All right. So the whole point was, how many beers does each brewer make? So basically, we want to count the size of this group. We want to count the size of this group, which is 2. This one is 9. if I remember correctly. Carlton seems to make a few beers. So we want to count the size of that group, and so on and so on. All right. So we want to focus on brewers, and for each brewer, we want to count the number of beers they make. And you could either use count name or you could use count star, you know, how many tuples involve the brewer from beers. And order by brewer, but in this case, we're not ordering by, we're doing group by. And that's probably why that was not there. That's the right link. Okay, so that will do the trick. So form that table with the tuples grouped into the same brewer, and then count the size of each of those groups. And we'll get something like that. All right. B, which brewers make only one beer? Well, we're halfway there. And we could answer one of two ways. One would be to turn this into a view and then do select star from this view where count equals 1. So let's do that. Create a view. N beers as this. Couldn't think of a better name, but there you go. So select. Gives us that. And to answer the second question, let me just say where. And that gives us these ones. 48. Clearly untrue. Oh, here's a collaboration beer. Not done in the same style as the assignment. How big of a project is building someone half comparable? Oh, is it like a thesis project or year long? Probably years long. Depends how complex it is. You know, if you're talking about something like the UNSW student database, that may have 100 tables in it. That's not huge. Designing the schema for that, well, you've got to work out what you want to do with all those tables. You know, obviously, you want people to enroll. You want to be able to produce transcripts. You want to do progression checking. As if they do. Like postcard. Oh, DBMS. Ah, sorry. All right. Yeah. And building a database system would take years. But hey, you've got Postgres, so you may as well use that. And interestingly, Postgres is open source, so you can get the source. And if you want to make it do something a little bit more than it currently does, you can hack the source. And starting from source code that has, 30 years of work on optimizing it. Oh, what a shame. You could always pay extra for it and do it outside load. Yes, indeed. All right. What's ME mean? ME. Or is that me? Will we take a little break? Damn fine idea. Well done. Thank you. My voice is getting tired. Yes. All right. We'll take a break and I'll show you the other way of answering this query that doesn't involve making a view. All right. Where are we? Pause the recording now. Okay, back again. Oh, I came back a minute early. Oh no, it's just ticked over to 5:10. All right. Yeah, so we were just answering this query here, which brewers make only one beer. And we did it using a view. Let's see, DV tells me, so there's a whole lot of variations of /D. And if you do \, it'll tell you everything. One thing, wow, there's more than I thought. Gosh, all right. Isn't PSQL clever? You can even do CD from inside. You can see you can turn timing on and off. But one thing you can do, what was that view called? Oh, NBS. We can actually tell you what the definition of the view is. And I think you can even edit it from inside. So \D+ gives you extra information about an object. I think you have to name an object. I don't think you can do that. Oh, okay. All right. It does give you a few. Oh, I don't think I've ever done this. That's interesting. Permanent. Wow. Surprise, surprise. It's a database. Everything should be permanent. No, it was red nut. The red ale. I don't like crankshaft, even though it keeps winning all the awards. All right, yeah, so database objects, permanent, good. Yes, quite right. Postgres is interesting because you can create temporary tables while you're asking queries. Obviously, it's kind of not going to make sense here because I'd ask a query and then I do \D+ and all the temporary tables would have gone. But if you've got multiple people using the database and someone's asking a query involving temporary tables, then I guess they could show up here as temporary. Size, interesting. They're all pretty small. Notice that the view occupies 0 bytes. Basically what that means is that it doesn't take up any disk space. Obviously it does because it's permanent, but it's hidden inside one of the database files rather than one of the tables, rather than being a separate table. All right, let's get off the track. Oh, yes, right. Let's go back, see if I can get back to, yeah, this one. Right, so the question was, which brewers make only one beer? Now, the size of the group, count star, is a property of the group. And so you can't ask it you can't ask this test in a where clause. However, no, all right. So views are not temporary. Views are permanent. defined views are permanent. I think what I might have said last time was that views, when you ask a query that uses a view, the view gets, if you like, expanded at compile time and stuck into the definition of the query. So it's not like views actually exist as tables. They exist as definitions that are inserted into queries that use them. Right, what was I saying? Oh, yes, all right. So the thing we're interested in, 1B, is a property of the group. It's the size of the group. And the way that you specify properties of groups is you say having. And you can say count star, which is the number of tuples in the group. And groups that have only one tuple are the ones we're interested in. So this should give us the same set of 48 breweries. That was an unfortunate one. I should have asked for 2 tuples or something that had less results. Let's try that, maybe 3. Yeah, right, so there's only 3. And we could find out, we could answer the query with select star in beers, number of beers made by a brewer, where I think it was also called count. Yeah, so you get the same set of tuples. Having is like a condition on a group. Exactly, that's exactly what having is. That's a good question. Maybe not. Maybe not. You could ask, you could test some other property of the group. Let's try that. Having Max brew. I mean, it's a bit of a stupid test. Yeah, well, that's what I'm trying to find out, to make sure that you can actually do group tests that don't involve the attribute in the select clause. Yes, you can. All right. Yeah, it is. It's a completely stupid test, but obviously it works. So if you're asking a query and there was some other property of the group that you are interested in, so it's basically a way of filtering out groups. In the same way that a where clause filters tuples, having filters groups. All right. Find beers that are the only one by their brewer. Okay. Well, we've got a table that tells us how many beers each brewer makes. Well, we've got a view that tells us that, and we could treat it like a table and find beers that are the only one by their brewer. All right, so find b.name from beers B, and we can actually do a join with the view, because it's kind of like a table. And we're joining on the only one by their brewer. Okay. Oops, on b.name equals, I think, in dot, actually that's totally wrong, isn't it? I think it's b.brewer equals n.brewer. don't need that, don't need that. But what we do need is a where clause where n dot count equals 1. All right, so we want to find all the tuples in the NBs table that have a count of 1, and then we want to find out what beers are associated with those brewers. So the beers table has a brewer, the NBs table has a brewer, so we do a join on those. And how do we know that's right? Good question. You'd have to ask another query and check. And which do I think is the best beer name in this list? That one. What a great name. I don't know what it means, but I find it amusing. Yes. Is there a simple way? I guess, you know, we could ask and here we're doing multiple queries. All right, so now we've found that the brewer is Bridge Road. And then we ask again, oops. Why did I write is? I'm not sure. Might even work, who knows? Anyway, equals. And I might need to spell select correctly. Right, and there you have it. So we worked out which brewer Bling Bling came from. And yes, thanks. Will is work? Well, let's test it. I don't think it will, but you never know. No, it doesn't. Is what's the context where is used? I suspect it's a keyword, yeah, because it's been colored brown. Oh yeah, of course. Is and is null. That's all right, because you can't use equals on null because nothing equals null. And that test equals null will always fail, even if the thing you're checking is null. So null doesn't equal null, but why is that dumb? I don't know. Yeah, so don't ever write equals null. It's always is null and is not null. The tests. Yes, if you like. All right, list of beers by each brewers. Well, hey, we've already done that, in fact. All right, that's good. We use string ag, if you remember. Oh, I'm a goose. I haven't been putting these things into files. Damn. That's very annoying. Oh, no, that means I have to go back and do that. Yeah. Or maybe I could just let you view them on the video. Which brewer makes the most beers? All right, once again we got a count of beers involved, and we've got a view that'll tell us about how many beers each brewer makes, so we may as well use it. So select from NBs. We don't want to select all of them. We just want to select the brewer from NBs. where, and this is an example of the most, the maximum. So we're going to be looking at the value of this, and we're interested in any brewer whose NB's value is equal to the maximum NB's value. Oops. Oh. And of course, it's not called NB's, it's called count in the table. Right, so get the doubles from the NB's table where the count, which is second column, is equal to the maximum count value in the NB's table. All right, so let's see, and there we have 2. How do we know that? Well, one way we could check, select stuff. Do something. What the? Oh, wow, that's interesting. What the hell was that order? I have no idea what that query just did. Actually, ordering by count. And then we see that Ben-spoken one drop of 9 beers. So they're the ones that have the maximum number of beers. And they're the ones that popped up in the query. This one drop Ben-spoke, different order, doesn't matter. All of these things notionally are sets. Yes, do not order by limit 1. Exactly. Yeah, and see, order by limit 1 would be wrong because there are 2 answers. Order by count desk limit 1. Oh dear, I got the wrong answer. I should have got these 2 and I got just this one. So let that be a lesson. Yeah, but okay, that's all right. You're being funny. Correct. Works every time, except when there's only one answer. Yes, don't use the limit. Find bars that serve new at the same price as the Goodyear Bay Hotel charges for VB. All right. I feel some views coming on. So we could do a view to find out how much the Goodyear Bay Hotel charges for VB, because we're going to get that out of the cells table. So select price from cells where and here's the reason why we tend to use numeric IDs and do joins rather than trying to do keys as strings. Bar equals Goodyear Bay Hotel and the reason I know that this is the right way to do it, I know there's a cells table that has bar and beer and price, and beer equals, maybe equals VB, but it might not be called that in this database. No, it's not. So here's another reason, Victoria. All right, so 4.3. So we can create a view. Ooh, caps lock. All right, so that'll wrap that up nicely for us, and notice that it's got a very long name. It's got a single row and a single column, so we can treat it like a number. See, if I spelt Victoria Bitter like you with a double R, it wouldn't have worked either. So all the more reason to avoid using strings as keys. When will CSC start? Yeah, funny boy. Over my dead body. If you want to ask that again, I'll play that video and give a language warning before it starts. All right, so we got that. And so the question was, find bars that serve new the same price as Coogee Bay Hotel. Oh, shit. Oh, I gave it the wrong name. What an idiot. We can fix that. Create view. BB price as select star from. And now all we've done is we've effectively set up an alias. You might wonder, isn't there going to be in a vision that we have to call a view that calls another view, da, da, da. Well, as I said, views get inserted into the query before as text before it's optimized and executed. So what we're actually going to run is really just the query that's the definition of new price at CBH. Right, now we got this. So what do we want to find out? We want to find out bars. Bingo, and we're done, and hopefully that's correct. And if you wanted to take a look, well, here's something that's a little bit helpful at least. Coogee Bay Hotel sells VB at the price that it sells VB for, so it's good. Oh no, but we need to know that it's actually selling new, so you could go and look at the full sales table to work out whether that's correct. And of course, if you don't like duplicates, we just stick a distinct in front of the bar. All right, find the average price of common beers. Common beers. What's a common beer? And then hint, hint, a beer is common if it's served in more than 2 hotels. So here we go with another group by and having. So first of all, we need to find out what are the common beers. Create. Select beer from cells. Oops. Oh no, actually, ooh, good point. Group by beer having sold at more than new hotels, more than 2 hotels. So hopefully You get those. How do we know they're correct? Well, we could do something like this. Then we'd see, let me see, what did I order by? I ordered by beer. Oh yeah. All right. So you can see new is sold at a lot of places. Old is sold at a lot of places, etc., etc. And if we just run that again, new and old, and right, so we've got a view that'll give us common beers. Find the average price of common beers. Ooh. So we can get an average price, and obviously we're going to need to group by beers, but we're interested in beers from the cells table, and we probably want to join. Oh, that's annoying. Common beers. I always make a little alias for tables, even if I don't actually use it, but I am about to use it. So S.beer equals C.beer group by that's it. Except, yeah, okay, it's good error to get. Anyway, beer is ambiguous because you can see here, beer occurs in the cells table and it also occurs in the common beers view, which you can almost think of it as a table. So we have to qualify the thing, and this is, it doesn't really matter because it's going to have the same name anyway, but we may as well. Group by, probably here we should group by the cells beer. Right, so that's the average price that all these things have. We can have a guess as to whether we're kind of correct. So this says 4.59. If we look around here, we got a 4.8, we got a couple of 5s, we got some 4.2, 4.59 looks kind of plausible. And I guess we're not going to prove anything by doing this, but it should give us the 4.59 result. All right. Average price also small. Is student attendance compulsory, or are we free to watch recordings? Tutor attendance is not compulsory. It's just good for your soul. Yes, you can watch the recordings if you like. If your tutor remembers to make a recording, it's really up to them to push the record button, something that I'm glad I haven't forgotten to do so far. Instead of join, can intersection work? Not really. Why do I use a Mac? Because I'm lazy and it's easy. I used to be a Linux user. I used to install my own device drivers, blah, blah, blah. That got boring after a while. So Mac does everything for you. Intersection isn't going to help, but we could do Let's see, select beer average price. Yeah, we could do something like this. So not use the join, but could do something like that, where the beer is a member of the set of common beers. That's not really an intersection, it's a nested query. So that would give us that same answer. Right, which bar sells new the cheapest? I'll leave that for you to do. Let's go on to some more. What is the cheapest beer at each bar? Okay, this is another pattern. So basically, all right, this introduces a new concept. Why do we need to select? Oh yeah, it wasn't ambiguous anymore. You are correct. It was ambiguous before because we had a join. So I could just remove all references to S and I'd get the same result. Oh, you could have selected C.beer if that's really what you were asking. So if you look back at the clause there, in the join, it was C.beer equals S.beer, so it doesn't matter which one you use because they're going to be the same. All right, here's a new concept, correlated subqueries. All right, so what is the cheapest beer at each bar? And these kind of queries can be answered by thinking something like this. So for each bar, find the cheapest price at that bar and then find the beer that's sold at that price, beer or beers, in fact. All right, so this is how you do it in SQL. So to some extent, from cells S is kind of like, well, for each cells tuple. Right, and here we've got the bars already built into cells. So for each cells tuple, find the cheapest price at this bar. Right, so here we do have to use S, and here we've got S down here, and that carries through from the parent query into the subquery. And so effectively, we run this subquery for each of the cells tuples using the name of the bar from that cells tuple. All right. So for each bar, find the cheapest price at each bar, which is what the cheapest price at the current bar, if you like, and then do a check on what's the or find all the beers that are sold at that price. So let me just check this so I can copy and paste this query. Well, and there you have it, the cheapest beers at each bar, we hope. Once again, we'd have to have a look. And also you can see that there are multiple beers sold at the same price at some bars. We're not actually asking what's the cheapest overall price, but that's trivial to work out. It's that 4.2. So the Regent Hotel happens to sell new and VB at the cheapest price. Why do we need? Yeah, exactly. All right. So that's the whole point of this correlated subquery. So like I said, this selecting from cells S is kind of for each cells tuple. It doesn't quite match what we got up here. For each cells tuple, evaluate this condition. And this condition is based on the current bar or the value of the bar attribute in the current cells tuple. What if there are multiple beers at that minimum price? They all appear. So here's 2 beers that are sold at the minimum price for beers in the Regent Hotel. Right, so yeah, important thing to think about is kind of, this gives you an iteration through all of the tuples in the table, and then this condition is evaluated for each of those tuples. And in this case, we're using a value for the current tuple. Good question. Could we do it with a join? Or would we even need it? Yes, good question. I'm not sure whether we could do something with group by. No, I think we'd end up going back to something like this. In fact, I don't think we even need this S1 here. I'll just test that out. What? Whether we need the S1 qualifier. Yeah, funny you should say that. That's what I was about to check. I don't think we do need it because we can disambiguate. But I was trying to make the point that this bar here is the local version of bar, not the one from the outer query. Oops. Yeah, still works. You're right. We don't need the S1 qualifier. I think it might have been put there just to make the point that here we're dealing with a different instance of cells, if you like. All right. All right, so correlated subquery is quite useful. Which bar is most popular, has the most drinkers? Once again, we use frequents to find the maximum number, and group by to find the maximum number of drinkers in a particular bar. Actually, now that I think of it, that might almost be worth doing. Which bar is the most popular? All right, so we could do a view n drinkers, which just gives us the number of drinkers at each bar. That's pretty straightforward. And then the answer to this query would be a select from bars where n drinkers equals select max n drinkers from the n drinkers table, if that makes sense. Which bar is the most expensive? Maximum average price. All right, so these are all cheapest beer at each bar. Which bar is the most expensive? This one is more interesting. Which beers are sold at all bars? So occasionally you get queries like which beers are sold at every bar, all bars, things like that. So what you need to work out is find the set of bars where a particular beer is sold, and then find out the set of all bars and see if those two things are equal. And if those two sets are equal, then you've got a match for a beer that's sold at all bars. So let's build this query up. And this is going to be done in a single query. Which beers are sold at all bars? So we actually do need the cells. We don't need the bar. And we probably do need the alias. All right, so here we're going to have a correlated subquery. So first thing, we need the set of all bars, and we can get that pretty easily. Select well, one might, since we're interested in cells, we can certainly do it like this. And then we need a set of bars where the current beer is sold. So S dot beer. Like I said, you can kind of think of that S as a variable that iterates over all the tuples in the bars. Potentially we could do that. I'll have a look at that example in a minute. But this is, why doesn't the counting method always work? Not sure. All right, we'll look at that anyway once we've done this. So the set of all bars where S is sold, select, we can do distinct, although it's not necessary at this point. Select distinct bar from and your suggestion is that we do a count of each of these. This is true, and then check that the two counts are the same size. All right, so let's quickly do that version. Oops. So really what we're talking about now is the size of, or the size of. Oh, look, I've slipped into C for a moment. Shocking. And like I said in the post this morning about formatting, I often do that in lectures, not in the style I would normally format things, but just to make it quicker to type. Right, so we got the size of all bars and the size of the set of all bars where S is sold, and critically that's this correlated value coming down from the main query is going to give us that result. And yes, I could then do equals. No, I couldn't. I could do equals. I'm not, I can't remember whether double equals works. I know for sure that PostgreSQL has an alias for not equals like that. I'm not sure that it has double equals as an alias for equals. We get no results. And that's true because no beer is sold at all bars. New is sold at a lot of them. No, it comes from the 1970s. So the question was, where does the not equal operator come from? Although then again, C existed then, so they could have just taken the operators from C. No, that's an SQL special. Maybe Pascal adopted it from SQL. All right, so this is unfortunate. There are no beers that are sold at all bars. So that's one strategy. Hey, what happened to my comments? You filthy swine. They removed the comments. Huh. Interesting. Whoa, 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 whoa. Okay. So this is the set of all bars. And this is the set of bars where this particular beer is sold. Unfortunately, SQL doesn't have a set equality operator. Damn, would have been easy if it did. So what you have to do is start from the set of all bars and then work out the set difference. If you remove all the bars that S is sold in, and only if the set of bars where S is sold is equal to the set of all bars, we're going to end up with an empty result. And that's something we can test. And I've forgotten the function to do it. I don't think it's empty. I'll have to look it up. No, it exists. Thank you. Someone's been paying attention. Yeah, it's good to see. It's all brown. Right, so that's an alternative way to do it, one which is commonly used in textbooks. Just make the point. I should be writing this to a file, you know. What is this? Q17. Oh, I can. You beauty. Should have done that all the way through, shouldn't I? And that gives us the same result, correct? Because no beer is sold at all bars. Let's see if I can fabricate that. This is how many bars is each beer sold at? Well, new is sold at 6 bars. What was the total number of bars? 7. Oh, so we're only 1 bar short. We can fake this. Let's see. So let's from Mhm. So which bar is, oops, which bar is missing? Australia Hotel, Coogee Bay, Lord Nelson, Marble Bar, Regent, Royal, local tap house. Yes, the local tap house has some taste, clearly. Mm. So I think the local tap house would sell new for almost nothing. Oh, silly. Always do that. Leave out that keyword. All right. Now, if we run these queries from before, this one ought to say new. All right. It shows us new 7 times, which is good. So if we really wanted, we could clean that up and get new. And let's see if we do the one using count. We don't need that, but we need count here. Make it equals because these things are both numbers. We don't need that. Hey, what happened to my where clause? Oh, what are you talking about, you stupid editor? Oh, I see. Caps lock. Oh. And we also get new from that. Yes, indeed, the joys of Vim. All right, this out to Q17A, oops, Q17A. Now that I'll finally. No, I don't. It's just that it starts doing funny things and you think, what the hell? And then you look down and realize caps lock is on. No, I don't think so. Thanks for the offer. All right, cool. How many drinkers are in each suburb? What's the time? Oh, what a shame. It's 6 o'clock. Yes, I'll finish that off tonight. Testing scripts was the question. Where are the testing scripts? There's only one testing script, but it's half there. It could test half of your solutions, but that's not going to make you happy, is it? I'll just add all the others tonight. All right, since it's after 6, that's it. I am going to stop recording.